Welcome to another teardown video. Ooh, we found some more RF devices. This time an attenuator, and this weighs absolutely nothing. It's probably just pure air in here. Look how thin and flimsy it is. So this is with end connectors, missing 2 screws and the other 2 actually a little bit loose, and the other one says Filter LF-Decoupler to probe MSL 300, so I guess this is 300 megahertz, I guess. End connector and B and C, so obviously they don't want people to mount this wrong. And again, there's no weight to this one, but all screws are here and they are not loose. All right, maybe we should try the attenuator first. I just took a male-female N, and then I just zero calibrated S11. So now I'm gonna see what this is doing. Since this is called something with 300, I guess I will be going from about 10 megahertz to 1000. Yeah, let's have a look. Let's check. Yep, this is all zeroed, so that works. All right, and we only got 60 dB dynamic range due to the bandwidth and levels and all that. So the attenuator is called 3 dB. Ooh, that is not 3 dB at all. So if I keep the marker, so in the 300 megahertz area, we are more talking about 3 to or about 6 dB, 5 to 6 dB. If I go all the way down to 100 megahertz, it's about 5 dB. All right, so that is not impressive at all. Okay, so let's try this filter. Oh, looks like somebody left it outside in the rain for a while. Ooh, something is here. Marker. Let's go to, wow, look at that. 300, so that is a filter that will deliver 300 megahertz at almost no loss. Look at that, only 0.7 dB is what you see here. So the insertion loss, let's just say the 1 dB point from 283 to 314. That is the 1 dB point. And wow, look at that. If we go below 100 megahertz, there's like really attenuation. And then there's a really good suck right there at 60 dB, 462 megahertz. So whatever this was used for, it gotta be something very specific. Ooh, look at that. Is that the... Ooh, it's sensitive for the plate here. I wonder what is inside this one. We gotta open and see, right? This is what we want. So how about we open the attenuator first? I think I'll go in here where 2 screws are missing. Oh, look at that. Self-tapping into aluminum, and oh, this is dodgy. Oh no. Some brown. I think somebody let the smoke out of this one. So this is your attenuator. Aren't you just impressed? Wow, look at that. They're different resistors on the input and the output. This is why we see the 6 dB, right? This is because this thing is not designed. This is not designed for 50 ohm in and out. Or what? Yeah, this is really, really weird what they've done. But I guess this one did blow up at some point. And also, I find this a little bit disturbing. That this plate down here at the bottom, you actually think this is supposed to be ground. But look, this looks like feed-through capacitors. I don't know if we can get a picture of that, make it focus. Well, this is what it looks like. So they're sticking them in here and then solder. That is just the weirdest. This is directly back to the dumpster. Again, let's open the other one. Okay, that was the last one. Whoa, look at that. What is that? So this is supposed to be a filter with 300 megahertz pass. Ooh, I know what that is. That is the length of the cable that gives you the 300 megahertz. Oh, so this is a cable resonator filter. Those are actually really, really good and sharp. And look at that. Somebody gave this a lot of power. Oh, it's all burnt. That is really, really bad. I think I'll open the bottom. Yeah, look at that. Ooh, I can even smell it all the way up here. F05. So this is high voltage overload of this area, or how the heck did this happen? But it really looks like feed through. Why can't I make this? Yeah, look at that. What is the point? So this whole area here is... Come on, man. That is just the weirdest way to do it. Yeah, what do you say? And then these two inductors. Aha, so in here we got capacity to... Is this the ground? No, no, no. And then it goes over here as well. And then this one is in series. And then this one. So here we have a series resonance or something. Why is this connected together here, up here as well as in the PCB? That's a little bit confusing. Why did they do that? And it is exactly the same in the other way. But anyway, the length of this coax is definitely the 300 megahertz. Of course I was right about this. See? I think it's easy to see if I show it like this. So here's the coax connected to the outside, which is shorted at that end, and then the other one is shorted over here. That is just amazing. I think maybe I can show this way. What actually happens. I tried to trim the filter up a little bit by making all the capacitors smaller, but now you see there's an overcompensation here. It's because I didn't change the length of the wires. So that means you can't really move this a lot because you're not moving the length of the cables. So all you do here is actually just trim for best impedance. Oh, of course I can't touch anything. See, I need to move this down a little bit and move this one down as well. See, now it's feeling good. And then remove again. It is really clever design. So the idea is you can trim for flatness and for low loss in this area. So I will be guessing you set this one for the 300 megahertz that you want as your pass frequency, and then you adjust for absolutely lowest possible loss at that frequency. Really cool and ingenious. Yeah, so I'm moving this back, see, and then this one as well, like that, and then I trim here, 0.5. Ooh, critical. That is a lot of fun to trim around in filters like this. Really smart made. I hope you enjoyed my video. See you.